Okay, now we're going to look at the cosine rule. This applies to non-right angled triangles also. Now the cosine rule is given here, written in the blue box. Now the notation is we say that the angles are capital letters. So we've got capital A, capital B, capital C for those three angles. Whereas the sides we use lowercase for the lengths of sides. And the side opposite angle A is called little a, opposite B is called little b, opposite C, little c. So lowercase is lengths, uppercase angles. Now with that in mind, we can look at the formula. This is called the cosine rule. It says a squared, that's this side squared, equals b squared plus c squared minus 2 times b times c times cos of the angle between them, cos A. So it's this squared equals that squared plus that squared minus 2 times that times cos of the angle between them. That's the cosine rule. They've got three others written there because you don't have to start off with A, you could have started off with B. Now the proof is there. We don't need to reproduce it, but rather than just accept rules, you can always see where it comes from. So you could plough through that if you would like to, but we're going to just apply it to some problems. So we'll start off with exercise 1J. So question 1, we have A being 105 degrees and B and C. This is 15, that's length little c. This is 21, length little b. Now to write the rule down, we could use it letters, but I tend to just write the numbers down straight off. Let's call the thing we're trying to find is the unknown length. We'll call x. So we can say x squared equals 21 squared plus 15 squared minus 2 times 21 times 15 times cos of the angle between them. Now we can put all of that into the graphics calculator. So it is 21 squared plus 15 squared minus 2 times 21 times 15 times cos of the angle between them, which is 105. Close the bracket, enter, and that's 829. Now that is an x, that's x squared. X squared is 829. We want x, we have to square root that. Now normally we do plus or minus, because we're dealing with lengths in this problem we only take the positive answer. So normally it's plus or minus, but we're going to take the positive answer. So on the calculator we're now going to do square root, second square root of the answer, enter, and so we get 28.8. So we can come back here and say 28.8 centimetres, and we're only taking positive lengths because length is positive. Okay, so you try B and C and check the solutions afterwards. And here are the solutions to 1J, 28, 3 and 14. Now we can use the cosine rule to find unknown angles. So I'll just do one angle in question 2, and you can do 2 and 3. So question 2, We have 3 sides, 12, 11, 13. And we're going to try and find, I'll do A, I'll put theta here. The first thing we do is write down the cosine rule. You start off with the side opposite the angle we're trying to find. So it's 11 squared equals 12 squared plus 13 squared minus 2 times 12 times 13 times cos of the angle between them, which is theta. We have to now rearrange this to get theta. So what we're going to do is we can do it all in one hit, or some people actually work out all these individually, but the problem with that, sometimes you have decimals, so I'll do it all in one hit, see if we can rearrange that all together. So we're going to do 11 squared, we're going to take 12 squared over the other side, we're going to take 13 squared over the other side, and then because all of this minus 2, 12, 13 is multiplied by cos theta, then we have to divide by all of that, minus 2, 12, 13. That all equals r cos theta. So we subtracted the 12, the 13 and divided by that whole product. Now you can put all of that in the calculator and then do shift cos. So if you want it all in one hit, it's actually like this. Theta is the inverse cos of this whole thing. 11 squared minus 12 squared minus 13 squared minus 2, 12, 13. And that will give us our answer. So we'll put that into the calculator. So we want 11 squared. First of all, we want to have a bracket and with inverse cos and separate the numerator and denominator. So we want to do shift cos, and I'm going to put another left bracket because I'm going to put in the numerator. So that's 11 squared minus 12 squared minus 13 squared. Now close that bracket because that's the whole numerator, and now we're going to divide by the denominator. So we start with the left bracket, and now we put in minus 2, 12, 13 minus 2 times 12 times 13. Close that denominator off, then put another bracket in because that closes the whole bracket for the shift cos. Now press enter, and so it's 52 degrees. So all of this is 52 degrees. Okay, so you try getting the other angles, and you could try 3 also. So just pause for your working. And here are the answers: 52, 59, 68, and 3 was 111.